Today we're going to be doing a video explaining really the concepts of indefinite integrals. If you watched my other video, I actually did some problems doing indefinite integrals. This video will be explaining the concepts of how to use it more thoroughly, as well definite and indefinite integrals. First off, like I told you in my other video, what an indefinite and a definite integral is just taking the antiderivative of said function. Whenever we're going to be doing this, we're always going to be having these two symbols next to each other. Anytime you have this dx, it's always going to be explaining to you to do the antiderivative of a function. You're always integrating something. Say you're doing the indefinite integral like you had shown in my other videos. We're going to be showing we just have said antiderivative, said function. What that's saying is we're going to have a function that we're going to have a prime that when we go reverse, we get back our original equation. When you do this, what we're trying to find is the antiderivative. When you go backwards, you get back the original function that you just had. So let's say I had 2x as my antiderivative. Well, it's a commonly easy known fact that if we were to go back, it would be x squared, right? So, say we have, say the antiderivative was x squared. What we would do then, it would actually be x3 divided by 3. You can plug that into Wolfram alpha, you can substitute any way you want to, but just know whenever you add a function, a variable raised to a certain power, and that's actually the antiderivative, or you can go back and take the derivative of this to get back that function. So, that's really explaining indefinite integrals, but what about definite integrals? What if you have a point B and an A mixed in with your integral? What that's saying is, on the x and y axis, on a said graph, say sine x. Okay. Say here is my B and there's my A. I want to find a point C, and I want to find the area within B and A. By doing the definite integral, we're going to be able to find out exactly what is that area, because every time you're integrating a definite integral, it's always going to find the area using those points. Okay, so to give you a better example, said you have that function, said you have 3 and 0, I don't know, maybe 3x squared dx. Okay. So we go ahead and find out our antiderivative, which would be, that's going to be a third power if we did that. That'd be x to the third. Because when we take the derivative of that, that's going to go back to 3x squared. Okay, so we have our point B and our point A. We're going to go ahead and do this. It's going to be thought of as f, the antiderivative B minus the antiderivative A. That's what we're trying to do here. So we're going to go ahead and do that. This is our antiderivative. So we're going to plug in B, 3 cubed minus 0 cubed. 3 times 3, that's 9. 9 times 3, that's 27. So now, because that's just 0, so 27 minus 0, that's just 27. By doing this, we can find out, using from point B to A, we can find our C, we can find our area. That's the whole concept and actuality of doing the definite integrals. There are some harder, more complex examples that we're going to be doing. If you're doing the homework with the same professor as I am, I'll do some more problems, and I will get back to you as soon as possible.